welcome to our latest podcast. I'm Dr. Marie Oldfield. I'm a chartered statistician, chartered scientist, and an advanced practitioner in AI. Today's topic is how do we use statistics in business? So that is a really big question. What I normally tell people is it takes us a long time to become qualified as statistics experts because there are a lot of methods, mathematical methods and statistical methods, theories, things that we need to know. There's lots of caveats on tools, how you use them, how you apply them, how you collect data, etc. And all of these nuances need to be understood. It's very easy for people to think that they can do statistics and they can go on Wikipedia and they can interpret the results when they've done something on, I don't know, R or Excel. However, the problem is if you get anything slightly wrong or you make the wrong assumption or justification within that, you will end up with something that's incorrect and that will mislead you. What that can do is it can mean that business decisions are impacted and funding goes to completely the wrong place. An example of this is when I was looking at students. So we were looking at where to send university funding for students. And at that time, the government had a category called BAME, Black, Asian, and Minority Ethnic, which in itself is ridiculous, but there we are, that's what we had. And this whole category was being analysed by itself. Now, if you look at Black versus Asian versus Minority Ethnic in this particular categorization, what happens is that you say you see the results and you say, oh, okay, Black students aren't doing as well, minority ethnic aren't doing as well, Asians doing really, really well. So that could be a conclusion, and you could start pumping money into a group that you think is not doing very well. Now, what actually happened was when we broke down these categories further, because obviously minority ethnic covers a lot of categories, Black and Asian covers a lot of categories. We broke these right down because I said, this overall category is going to be skewed. It's going to be pulling one way or another, dependent on what's going on within it. And there could be a lot of variance within what's happening with, say, different countries in Asia, or if you've categorized it by geography, or different cohorts of Black students. So let's have a look at this and see what's going on. So when we got down into it, it turned out that there was one small cohort within the Asian category, and the Asian category was seen as being really high performing. But because this cohort was small, but it was doing really badly, it wasn't really showing up in the analysis because you couldn't see it because of the effect that the large Asian category had that was pulling it up. When we found this small cohort of students that were doing poorly, what I suggested was we find out why they're doing poorly. So it's easy to say, well, look, there's this group of people and they're not doing very well. Let's just throw funding at it. Let's put some more money into study halls or study support. Now, what was actually happening when we went out and we spoke to these students was they had to work. So what was happening was they were at work, they were then getting up late or finishing work late, and they couldn't meet the timetable times for their lessons. So what needed to happen was, in this case, just move the lecture an hour later, and that increases attainment. So you can see how complex this is. It's not just a case of, oh, I've got all this data, let me just have a look at it, or I've got all this data, let me shove it into a machine learning tool and see what happens. The machine learning tool has no understanding or discriminatory ability about what is in this data, what's going on, how does it work, what is the human factors behind it. Doesn't know, it just processes it and throws you out results, which is great until you get to the point that I'm talking about where you need that granularity. Here, we had a no cost movement. We didn't have to throw any money anywhere. We didn't have to spend anything. And we got increased attainment. We got a quick win. It was a big win. Great. But what would have happened if we'd thrown millions at study halls? Nobody's using them because they actually didn't need them. What they needed was a different intervention. So this is where statistics becomes connected to, well, it is connected to humans. It's about humans. The data is about human behavior and societal behavior and processes. And that is how we analyze what's going on in the world. But we've got to understand that world and we've got to understand that data. And then moving from that, understanding that part of it gives you an indication of the tools that you need to use to understand movement in the data, variance in the data, changes in the data. There's lots of tests you can do. You've got to understand the data to be able to do these tests. You can see in my published papers that historically some of these tests are used pretty badly. The right tests are not applied, the right samples are then not taken, the analysis is poor, it's misleading, and some of this is to do with safety in medical interventions. So, again, looking at who's funding that, what type of approach they're taking, what the methodology is. And I would highly recommend that if you're doing anything with high stakes work, particularly with everything, you should be doing this. But with high stakes work or court cases or medical interventions, large government programs, etc., you need a chartered statistician because they are credible, they're certified by their professional body, they know how to use all these tools, and they've got an in-depth understanding and expertise. So I would say, if in doubt, use a chartered statistician. Now, people say, oh, that's somebody else I've got to bring on board, it's somebody else I've got to pay for. Yeah, and we're getting there with a lot of professions now, aren't we? I mean, cybersecurity professionals. How many hacks have there been recently? How much data has been taken? How many ransoms have been paid? We're starting to see through that the utility that these professions bring, and it shouldn't be that we're seeing that now. We should have already been using it. We wouldn't say we're not going to use a project manager for a project, but arguably, project managing might be a bit easier than the mathematics behind the statistics. We wouldn't say we're not going to use an HR person for HR, and in the same vein, we should be using mathematicians, statisticians, all the chartered professionals that we've got, because we've got a lot of professional bodies that accredit people that have the expertise and that are qualified to do the work. We need to use them. So we need to use the chartered AI professionals, the chartered statisticians, the chartered IT professionals. We need to be using them. And that means that these teams that are developing software and AI become a bit bigger. But what they also become is more robust, more ethical, more communicative. They've got more skills. You can get things done a bit quicker, you can get things done a lot better, and you minimize, and this is the key, you minimize your financial and reputational risk. And that's what you want to do. You don't want to be in court. You don't want bad press on social media. You don't want to be doing unethical things. You don't want to be damaging people. And that is the main thing that we need to be concentrating on moving forward in using business statistics, programming software, doing anything like this that's going to affect people. Hope you enjoyed that. Like and subscribe. Let me know if you want any other content, and if you've got any questions, let me know and I will answer them. Nice to see you again.